In this video, we will talk about receiver operating characteristic curve, so-called ROC curve, which is a measure of the performance in machine learning classification model. So first we have to introduce confusion matrix. So in a confusion matrix is an important way to evaluate the performance of a classifier. So the general idea is to count the number of times instances of class A are classified as class B. So if we look at this table, these are confusion matrix. So for each row, represent the actual cases for the negative or positive. And for the column is for the predicted case for the negative and positive. So these two green field is called true negative, which is the actual is negative and classified as also negative. So similarly, this is for called true positive, so TP. And these two yellow area is called false positive and false negative. For example, this is actually is positive, but is classified as negative. So this is the fail. And from confusion matrix, we can get two metric called precision. Precision is the true positive divided by the true positive plus false positive. So if we look at this column, so the area of true positive divided by the sum of false positive and true positive. So this is precision. So which means in the case of old classified as positive, how many or how much percent is correct. So this is the precision if we look at this column. So another metric is called the recall or sensitivity or true positive rate. So this is the division of the true positive by true positive plus false negative. So if we look at the rows, for this row, so this is the total positive. So the recall is a measurement of how much percent or from the total positive which are classified as positive. So this is the ratio of the true positive divided by the sum of this yellow area and green area. So you cannot have it both ways. So both the precision and the recall will be higher is better, right? But usually we cannot get it in both ways. So increasing the precision usually will reduce the recall and vice versa. So this is called the precision and recall trade-off. From this curve, this is the precision recall curve. You can see, for example, when we increase the recall from 0.4 to 0.6, and the precision will decrease from about 0.9 to 0.8, right? So the receiver operating characteristic curve is another common tool used with binary classifiers. So it is very similar to the precision recall curve, but instead of plotting the precision versus recall, the ROC curve plots the true positive rate. True positive is also called recall against the false positive rate, so FPR. False positive rate is the ratio of the negative instance that are incorrectly classified as positive. So it is equal to 1 minus the true negative rate. So this is the ratio of the negative instance that are incorrectly classified as positive. So actually is negative but classified as positive. It is 1 minus the true negative rate. So the ROC curve is measure the rate between the true positive rate, which is the division of true positive by the sum of true positive and false negative by this row. And this is the true positive rate against the false positive rate. So false positive rate is, we look at this line, this row. So false positive rate is this yellow area divided by the sum of this green and this yellow. So the false positive rate actually is 1 minus the true negative rate. So true negative rate is also called specificity. So the ROC curve measures the true positive rate against the 1 minus specificity, also called false positive rate. So this is ROC curve. So the horizontal axis is the false positive rate. Is 1 minus true negative rate and 1 minus the specificity. And the y-axis is the recall or true positive rate. So once again, there is also a trade-off between the higher the recall, the more false positive the classifier produces. And the dotted line represents the ROC curve of a purely random classifier. So this is the dotted line. So if we use a purely, actually no module, is a null module, so we can get this line. So good classifier will stay as far away from that line as possible. So this is ROC curve. This ROC curve, if very close to the top left corner, so it's better. So one way to compare and classify is to measure the area and the curve, the area under the curve called AUC. So a perfect classifier will have a ROC AUC area equal to 1. And a purely random classifier will have ROC AOC area equal to 0.5. So if the total area in this curve is 1, the best classifier will have the area equal to this rectangle, which means the ROC curve will be the y-axis and then the horizontal axis, right? But the worst odd null model will have this is ROC curve and its area is 0.5, this triangle area. So in this case, we have the ROC curve here is almost 0.9, almost, right? So next we will show the Python code to plot the ROC curve. First, we will introduce the module, several module, and run several functions, and then load the data. We will skip this module very quickly because the main code has been shown in the previous videos in this playlist. If you are interested in, we learn very quickly, skip this part of the code until we go to the ROC curve. So now we just load the data for mixed data, for image data with the handwritten digits. We show one target value is 5. The first observation in this data. Then we set alt y value to numeric type. You create plot function for the digits, and we show the first 100 digits with 10 rows, 10 columns. Y0 is 5. So next we set the training data for X and Y. And we set the Y data as the target label as 5 or not 5, both for the training and test data. So we load the module for the SGDC classifier from scikitlearn linear module. So next we train the module with X tree and Y tree 5 for the binary classification. Take about 1 minute. Train finished, then we can predict this observation is true because we have seen the target is true, and this is the prediction result is also true. So the model prediction is correct. Next, we import the cross validation module, which will train the module and look at the performance based on folds, 3 folds. So each time we'll train on 1 fold and train on 2 folds and evaluate the module on 1 fold. Then look at the scores for the accuracy. Will also take about 1 minute. Training finished. You can see the accuracy about 0.93 to 96 for different folds. And this time we'll also use cross validation, but first we import the stratified fold module because we'll think about how many cases is 5 and how many are not 5. Then we'll keep this ratio, then create the folds. So folds is also based on this stratified sampling. But this part of the code is actually a cross validation. So take 1 minute. So this is the first fold being tested and trained. This is second. You can see the result is quite different from the previous learning without the stratification. Finished. So next we will run a module. Actually, is a base estimate. In the base estimate, we always predict in the fit process we pass, and in the predictor we always use 0, which means we always will predict the observations as not 5 case. So this is 0. The model finished, very quick. Then we also use cross validation. You can see the result is about 0.90. So why? Because even we do nothing, just predict is negative for all the cases, because there are only 10% of images like 5, 90% are not 5. So which means we get 90% of the accuracy, right? They are not negative, but we predict negative, so they are correct. So next we import a module called cross-validate predict because we will get the scores, so-called scores, which will be used for confusion matrix. So first, we will use cross-validate predict. It also training module, very similar as the cross-validation training we have used in the previous lines. So the result will be assigned to an object called yTrain predict. Then we import the confusion matrix module, and using the function confusion matrix, get the confusion matrix with the input, the training data, and the prediction results. So this is the confusion matrix. This true row, true column. This is the true negative, false positive, and this is the false negative and true positive, right? If we use the true data as the prediction data here, then we will get the confusion matrix, a perfect confusion matrix with 0 int error. So all cases will be predicted correct. So next step, we will create the precision. First import module function, then create the precision score 0.73 about. And we can also manually compute the precision from confusion matrix. Same result. Then for the recall, we can do the same way. Recall about 0.75. Then we can get the same result from the confusion matrix for the recall. And another measure is called F1 score, which is the combination of recall, precision, and recall. Can manually calculate the F1 score. Here, same result as the function result. So we can show something about the precision recall curve. So this part of the code will calculate the precision recall curve. Take 1 minute. So precision and recall for the different thresholds, and the threshold will compare with scores for each observation, and the score is the result, model results for each observation, decision score. So next we will plot precision recall curve again, another type which we have seen in the PowerPoint file. This is the recall and this is the precision. Trade-off, very clear trade-off. And create some parts. So next we will go to the part of ROC curve. So first we have to import ROC curve for the receiver operating characteristic curve from scikitlearn matrix. That's quite easy. You can use ROC curve for the yTrain and y-score. This is training data and this is the y-score from the model training result. We can define a function to plot this curve. So this is ROC curve is same as we have seen from the file, PPT file. Next, we will run a module called the random forest classifier. Then use the cross validation predict function we have seen. Take a while. Random forest is to use the called ensemble modeling for the classification, because in each run, different run take the different variables into account in the classification. Then in the end, we'll combine this result from different modules. So this is called ensemble learning. Model training finished. Then we can take out the score. In the random forest, it's not direct score, but we can take the probabilities as the score. Then use this score. We can also got ROC curves. The next code we will show in ROC curve for this module. So you can see this line represents the previous ROC curve. Then we used random forest. We'll get the better ROC curve, right? Very close to the corner. So this is the SGDC curve we have trained before random forest. I can also calculate the area under curve. About 0.998, so very close to 1. You also get the precision for this module. You train again. Take about 1 minute. can see the precision 0.99. So if you remember the last time SGDC module is only about 0.72, right? So it's much better. I can also get the recall for this random forest classification. Recall is 0.86. The last time we saw about 0.74 in SGDC classifier. Thanks for watching.